The world of quantum computing, it's just this chaotic gold rush, right? You've got millions, maybe billions of dollars chasing all these wild, almost magical ideas. I mean, we're talking about freezing atoms to absolute zero, trapping ions in these tiny gold cages, or even just shooting lasers through glass. It is a super confusing, really high stakes race.
And then one day, bam, a headline screams that some tech giant has totally cracked it. You think to yourself, okay, I guess the race is over before it even really started.
But hold on, because the very next week, a different company using a totally different method claims they've just set a new record. Suddenly, the goalposts have completely moved. And just to make things even more confusing, a third group pops up and they're promising that their method, using light itself, is the only one that can actually scale up. So you've got everyone chasing their own version of magic, and we're just left here trying to make any sense of it all. Which brings us to the real problem, right? How are you supposed to invest in a race where the runners are literally subatomic particles and the finish line is like a decade away? How do you find the signal in all this noise, especially when the scientists themselves are still debating the fundamentals? Now, your first instinct, everyone's first instinct, is to try and pick the winning horse, to bet on the right technology. But what if I told you that's the completely wrong way to look at this? That you're asking the wrong question entirely? Okay, let's really get into this. The key is to shift our thinking. We have to stop looking at this as a pure physics problem and start seeing it for what it really is, an engineering challenge. And trust me, that one little shift in perspective, it changes absolutely everything. So here it is. This is the absolute crux of the whole thing. It doesn't matter what your qubit is made of. It could be an electron, a photon, a trapped atom, whatever. To actually be useful, that little quantum state has to be controlled, it has to be read, and it has to connect back to our normal classical computers. And that universal language, that bridge between the quantum world and our world, it's silicon. All right, so with that new engineering lens on, let's take another look at the four main contenders in this race. We're not going to ask which physics is the best. No, we're going to ask a much more practical question. What do they all need to build a real machine? Okay, now look at this, because what's really fascinating here is the pattern that emerges. Up at the top, you've got the current leaders, right? Superconducting, that's the one with the supercooled circuits, and trapped ions, which, holds atoms in place. For those guys, a company like TSMC is basically a supplier. A really important one, mind you. They build the critical control chips. But now, look at the bottom two. Photonics, using light, and silicon spin, using electrons. For them, TSMC's role does a complete 180. They're not just a supplier anymore. They become the primary manufacturer of the quantum processor itself. So we can really boil that whole complicated table down to two very simple outcomes. Scenario one, the big mainframe guys win, the superconductors and ions. In that world, TSMC plays a crucial role making the advanced chips that control them. That's a solid win. But in scenario two, if the scalars win, the ones built on photons or electrons, well then TSMC isn't just making a part of the system, they're making the entire thing. The chip literally is the computer. And this, right here, is the core idea. It's a classic case of heads I win, tails I win bigger. It doesn't matter which horse crosses the finish line first, because they all have to run on the same track. In one future, our hidden king is a critical supplier. In the other, it becomes the entire industry. Okay, so I know what you might be thinking. What if some new discovery just comes along and changes everything overnight? And look, that's a totally valid fear in the world of software. But hardware is different. It has this massive protective moat around it, and that moat is built out of time, concrete, and steel. Yeah, you can't just download a semiconductor factory like you can a new AI model that pops up in a few weeks. This is what it actually takes. It's a 5-year, incredibly intensive physical process just to get from breaking ground to producing a single chip. And that slowness, that's not a bug, it's a feature. It's a shield. You can see the competition coming from years away. And then there's the cost. We're talking $20 billion for one factory. This isn't some startup in a garage. This is basically a nation-state level of investment. It creates this enormous barrier to entry that almost no one can cross. So the key takeaway here is this. Even if someone made a revolutionary physics discovery tomorrow that made silicon totally obsolete, The industrial capacity to actually build that new thing at scale, it doesn't exist. It would take a decade just to construct it. The incredible inertia of hardware, it buys you time. So this all brings us to the real conclusion here. We need to stop thinking about a company like TSMC as just a chip maker. That's not what it is anymore. In the context of quantum and really any deep technology, it plays a much, much more fundamental role. Think of it as the physics to reality converter. It's the industrial engine that takes a wild science project from a lab bench and turns it into a reliable, mass-produced product that can actually change the world. And you know what? In the 21st century, that capability might just be the rarest and most valuable on the entire planet. So from now on, when you see one of those crazy headlines screaming about the next quantum breakthrough or some new qubit record, instead of trying to guess who's right, I want you to ask yourself a different question, a much more powerful question. Would you rather bet on the magician who promises to pull a rabbit out of a hat, or the only carpenter who knows how to build the stage? That's the real power of shifting your perspective and asking the right question.